Okay.
Hello and welcome to Identerati Office Hours. I'm your host, Mike Schwartz, founder of Glue, and today is episode 65. Improving Bank Mobile Security is the title, and our guest today is Anders Rundgren, bank cybersecurity expert and PKI guru. Welcome, Anders.
Thank you very much.
Michael Buckland was supposed to, from Cybernetica, the legendary Estonian PKI company, was supposed to co-host today. We haven't seen him yet. We might add him later if he pops in. But for now, we're just like we do always. We're just proceeding, going with the flow.
Yeah.
And Anders, maybe before we start, you could give everyone a quick idea about your background and how you came to identity and payments.
Okay. Well, I am what they call a seasoned engineer. That is a finer word for old, I guess. And I have been in high tech for 40 years or more. And everything from compilers to DNA deciphering. But the last 25 years, I've been in security. And I had roles at RSA Security in the office of the CTO, and my last regular job was for a company called Keyfactor, which is a PKI expert. And they have, for example, created the Swedish Bank ID, which has been a huge success in Sweden. It is used, it's like an EID using a mobile app, and about 70% of the population uses it.
And really, it was one of the first mobile bank
yes.
IDs, I would say.
Yes, it was rather simple to do in Sweden because Sweden have a unique identity system, or rather Scandinavia, Estonia, and a few other countries have a system where you get a citizen number, and that citizen number is valid in all registers. So you don't need, with a single identity, you can access any number of services in the public sector, but you can also access most of the banks as well. So it's very convenient solution, and I guess at this stage also rather secure. But it's an entirely proprietary solution. I don't know so much about it in the inside. I only participated in building the certification authority.
Okay.
Anyway, yeah.
I'm sorry, go on.
Anyway, 10 years ago, I was at the W3 meeting in China, and that was the starting point for a payment adventure in W3C, and I got interested in that and followed it. I am not a V2C member, but I have always been associated with their mailing lists and so on, and provided comments. And at the same time, I started building some kind of wallet because I felt that the success with mobile bank ID could be translated into the payment area as well, but preferable using an open source solution, particularly an open solution. I think that should scale better, and I had already been working with open source before, so at the Keyfactor. So I am very much into open source. Okay, and I find that the payment industry is maybe not the most advanced user or the most advanced IT kind of industry, that we still are struggling with security in online payments after more than 30 years is sort of a sign that something isn't completely right. So it makes sense doing something. I have some notes here. But just check this. Yeah.
Well, let me
Yeah.
dive into some questions
Yeah.
because I think what I see that you comment a lot on LinkedIn as sort of like out- an outsider who has a skeptical view of the current technology,
Something
but
like that.
normally, yeah, I find that your technical insights are have some merit, and it made me curious about sort of how you were thinking about this problem. But
Yeah.
before we dive into that, maybe we could start at a high level because there's a lot of identity wallet projects in the EU right
Yes.
now.
Yes.
And we had a previous guest on episode 31. We had a guest, his name was Dan Robertson, and he
Hmm.
described something he called the three wallet problem. And that
Yes.
is any given user will develop a strong resistance to decentralized identity products and platforms by the time she is forced to adopt the third wallet in the course of such solutions. So it's
Yeah.
basically the idea is you love the first wallet, the second wallet you're like, oh, I don't know, and the third wallet you're like, oh, this is a terrible solution. But do you see um, and you, it seems like you've also been wondering about some of these existing trends in EU identity wallet, but do you agree with that? And what do you see as some of the challenges there?
There are quite a bunch of challenges. They have a very aggressive timeline. They're supposed to go live next year or maybe a year after that, and that is very quick. Then they also say that all countries must provide, it's a law now, provide an identity wallet for their citizens. And that means that it's possible that there will be hundreds of wallets. I see a slight problem creating a unified identity solution based on hundreds of wallets. Even if there is a standard, checking interoperability will be costly.
So Dan Robertson says three is a problem. You're
Yeah.
saying hundreds. How do you get to hundreds of wallets? What would that
There
look
are other
like?
people that say that there are some 25 EU countries, and they expect that there will be private wallets and the government supplied wallets, etc., and there will be some competition within countries. I
Hmm.
don't really see the point with competition on the wallet side. The competition can rather be on the other side, the service side. Uh, but that is
I kind of
something.
agree with you. I see the wallet almost as like a new kind of browser. Like,
Yeah,
how many browsers do we have? The browser is sort
exactly.
of like almost an agreed upon operating system for doing stuff. But why do we need five? I think that the market's consolidated. Now we have maybe five browsers total, and maybe that's too
Yeah,
many.
yeah, exactly. Yeah, I totally agree with that. I feel the same, and that is something I guess the EU must learn, because, like say, in Sweden and in Denmark and in Norway, there is just one or maybe two solutions, and they have worked pretty well. So, but now we're talking about something that is supposed to work cross-border. That is new, and if I have a slight problem that with all these wallets, who is going to maintain them? Since I actually write wallet code, I can say it's a challenge with all these versions of operating systems, new
Hmm.
security features, and all the time. So you will have to work constantly to keep it in shape. And that's rather costly. And also then we have distribution, how are we going to distribution? It's difficult. I can't solve that problem. I think the market or maybe the people behind this project have to rethink this a bit.
Right.
So
So you're concerned about there being hundreds of wallets and how difficult that would be for the countries to support. Dan
Yeah,
Robertson is concerned about there being more than 3 wallets because how many will users actually want to use before they get disenchanted with the technology? But I
yeah.
would raise actually a third issue, which is how do we create the trust? Because, just to give you an example, here in the
Mhm.
United States, the first, and there was the TSA, they're the Airport Authority, the Transportation
Yeah,
Security. They agreed to accept mobile driver's licenses at an
yeah.
airport
Uh-huh.
as proof for getting onto a flight, but
Yeah,
only from the Apple Wallet.
yeah. That is
So
true. So
So
yeah,
I see this new trust challenge where
mm, it is.
we used to only have to trust the issuer and and let's say the verifier. Now we've introduced this new piece of software which is holding
Absolutely.
the credential. And so, in addition to the usability and technical challenges, there's also this rules challenge that I see with how are we going to create trust that these wallets are patched properly, let alone
Yeah,
using innovated properly for the latest features.
absolutely. Yeah, this is a major issue. And they also talk about certified wallets. I mean, certifying hundreds of wallets, it's expensive, and keeping track of them, if you have relying parties all over the place, all over Europe, or maybe even globally, that get out of hand. To me, the risk is actually that Apple ends up with all the business, Apple and
Well, I
Google,
think
because
de facto maybe what's sort of happening. As a software vendor, when you talk about certification of these wallets, there's another movement in open source around this thing called SBOMs,
Mhm.
software bill of
Yeah.
materials, because at Glue we are a vendor of an enterprise piece of software, and we're constantly scanning that for CVEs, critical vulnerabilities,
Mhm.
and then patching them. And we release monthly. And there's sort of a nonstop flow of these CVEs. Like I look and everything's great, and I come in the next day and there's a critical vulnerability because some dependency we're offering or we're using has a vulnerability. So I think that the point that you raise about how hard it is to actually release software, if we're talking about hundreds of different wallets, how
Mm.
hard it will be to actually keep those things patched for every like platform.
Yes.
It seems very, very difficult to me. And then how do you even convey that trust? Because I need to deliver you an SBOM so
Yeah.
that you can understand. And that delivery of the SBOM itself is actually difficult because if we can somehow hack the SBOM,
Mhm.
and or the delivery or of the SBOM or any of the signatures on the SBOM, we can also undermine the all bets are off on the integrity of the app.
Yeah.
So I do kind of agree with you that people are they don't understand why the TSA only trusts Apple to do this.
No.
Um,
Yeah, that's interesting. Well, this project, the EU project, is relatively new, and I guess the people involved are not really experienced with this kind of large scale thing. It has never been done before.
right.
So you can't compare it with, let's say, the stuff in China, like Alipay. It's just one company that they can control all pieces. But here we have a more dynamic system, so it will be a
Thank
challenge.
Yeah, and in a way, the Swedish bank ID got adoption because it was one thing, and it was
Yeah,
easy for company to say this is for the relying parties to say this is how I accept it and this is
yeah,
how I can trust it. And
yeah,
in a way, maybe even though it's not open as you would have hoped and based on open source and open standards, it did get adoption just because at least it had one path for implementing it.
yeah, yeah. It sure got
Well,
fine.
let's pivot to payments now,
Yeah,
because
yeah.
this
Okay.
talk is
So
actually and identity and payments aren't the same thing, but let's just
no,
leave it at we have some questions about the current European identity wallet situation.
yeah,
But you've proposed a payment solution called Saturn, and
yeah,
maybe you could set the stage for by explaining
yeah.
the difference between a payment system and a payment authorization system for end users.
Okay, good. Okay. Yes, a payment authorization system is usually we're talking about it's the user that have a request when you are in a shop and you put in your card in a terminal or swipe your card, you are doing an authorization. You have a request from the merchant and you say yes in some way by nowadays swiping your card. It seems to be, at least for low value payments, that is sort of the norm. And then you have authorized it. And the authorization create a signed object. This object is then sent to the backend, payment backend, and eventually ends up in the issuer bank where it is verified. And if it's correct, then the actual payment take place. So authorization is a separate step, and it's not the actual payment. But that the thing I am working with, and also the EU is working with, is just the authorization step. And it's complex enough. Payment is another, it's more a back-end process with clearing and settlement. And that is something which is outside of my horizon. I am not even particularly knowledgeable about that part. It's essentially what's happening between banks when you do a transaction. Of course, if you move money from one bank to another and it's all digital, one must count down your account and the other must count up the account, that the receiver account. And
right.
so that is a specific technology, so which is rather unrelated actually to the authorization.
Right, and this existing payment system today is EMV. I think the Eurocard, Mastercard, Visa, named after those companies that developed it. And this
Yes.
EMV system is what we know. It's based on chips, basically a card and a chip or a chip and pin. And this
Yes.
system is currently used. What does Saturn, the system that you're proposing, add over the current EMV system?
Okay, quite a lot. The core ID is actually a direct rip-off of EMV. That is essentially that you get a request, you sign it with a key that you have in EMV, usually in a card, but in Saturn it's in the mobile device. Hopefully in a trusted execution environment or an even better solution. So you get a request, you see it on the screen, and you sign it with a key that belongs to a payment credential. A payment credential is a virtual card. So the principle is identical to EMV, but the protocol is not identical because this protocol is intended to work on the web as well as in a shop. And that requires a different security model and a
Would now
different.
be a good time to show the diagram?
Yep. The
Should-
diagram. Okay, we can take that. That's fine. If you have
Is
it.
now a good time to show that while we're talking
Yeah,
about the
that could be
protocol?
nice. That could be nice.
Okay, let me just show
Okay.
it.
Yeah.
Th-
Okay.
This is our one diagram for the episode, and it basically is a sequence diagram that shows the payer, the wallet, and the payee or the merchant.
Exactly.
So
Yeah.
maybe you could walk us through this. And this is the new sort of protocol that you're talking about, right?
Yes. And it's actually, as I said, very similar to EMV, but the protocol is slightly changed because it's supposed to work in a mobile phone and over the web as well. So, and that requires slightly different security arrangement. The process is that you in some way indicate that you will pay, and that is like swiping your phone or opening a QR code. And what you
Mhm.
get then is a URL. And with that URL, you fetch the actual payment request, which comes from the merchant. And the payment request will be rendered then on your mobile device. Then the user comes in and can select a payment credential if he or she have more than one card, virtual card, and then you authorize it with a biometric operation or a PIN code. After that, this authorization object is created and sent back to the payee, that is the merchant. And it contains an exact copy of the payment request. So the merchant cannot do anything, cannot change anything without screwing up the signature. But the merchant is just a first stop. Now it is time to call the payment network. This system is not fixed to card payments, although I call them virtual cards. It can be any account system. That is something that differs from EMV. That means this uses a universal account concept. So the backend can be quite different, and it depends then on the payment network. So if the merchant have got, let's say, a SEPA payment, it will send it to the SEPA network. If it is rather a Visa MasterCard, it sends it to the appropriate Visa or MasterCard network. So this is where you have the flexibility.
I see. So in order for this to work, though, would these payment networks need to know how to validate this authorization response that you've created?
They cannot really completely validate it. It's only the issuer that can do that. That is the case for EMV as well. What they do need to know is where to send it, because for card payments, you use the card number. The card number, some of the numbers there indicate financial institutions. So you go through some kind of database to find out the proper URL. And for SEPA, there is a different system. So the payment network must do the routing of the actual payment, figure out which financial institution that this authorization belong to, or payment card. So but this part is then payment network specific. I am not going to design it really. The only thing that the payment network must support is the format of this authorization object. And it's identical for card payments or SEPA payments or a local account network. Only the account details differ. There are some new things added since SEPA do not have there is no database where you can take a IBAN number and convert it into URL. The URL is actually a part of the authorization object, and it's delivered in clear. And my idea is to deliver the financial institution as a host name only, and use this what is called now something now I've lost it, best known or well known extension, so you can actually get the proper URL from a DNS lookup.
I see. Right. So you can do discovery
so
in
you
order
get
to
away
get.
from this centralized database. That's completely unnecessary. Anyway, after processing in the payment network, you get a response, and it's of course sent to the wallet, to the merchant, which in turn informs the wallet about the result.
Right.
So this is a basic flow.
Right. I'm going to.
You wondered a little bit about differences compared to EMV. One is this universal account concept. Another is the support for recipes that has receipts that has not been dealt with by payment organizations. They have proprietary solutions where you have to register with merchants or something like that, or a specific payment network. I consider that, well, it works. I have created a solution where you don't need to register anything. The payment request contains a URL. This URL is a randomized in a randomized format, and when the purchase is done, the merchant is supposed to provide a receipt at this URL, and the local application, the wallet, it will pull this URL for the actual receipt. And since it is just a randomized URL, it means that the user is unknown. That has been one of the things that are most important in Saturn, is to not leak personal information more than necessary. And that is also an addition to EMV, that the authorization object is encrypted. So when it is validated by the issuer, it is first decrypted and then the signature is validated. So it means that personal information like account number and also the public key can be used as an identity. So you don't want to leak the public key of your signature either. So this actually goes through the payment network unmodified and encrypted. So I call it end-to-end security, both from confidentiality and from modification through signatures. So this is...
So I wanted to ask a clarifying question on the receipts. So right now you said that, so after, let's say, the payment gets processed, and the vendor gets notified, everything's okay, the phone gets notified, then you have a last step that the wallet can pull for a receipt.
Yes.
So what you're saying is that today, sometimes I get an email notification a little bit later that says, oh, I'm sorry, the payment didn't go through, or, oh, here's your receipt. But what you're saying is that the wallet itself could actually confirm, because it has a proper way to track this authorization request. It can say, hey, I know you said okay, but did it actually really post okay? Is that what you're saying?
Yes, assuming that the merchant has got a go-ahead, that means that the request to the payment network have succeeded. It will create this receipt. Otherwise, the purchase will be disqualified or not go through. So that is what it can do. And it's not a very complex solution at all. But I still made it as a defensive publication because there are so many people who try to sue people for stealing inventions. So I everything that could be novel, I don't know if this is novel, I publish as a defensive publication to destroy potential IPR. That is sort of the idea behind this. People wonder, they ask me all the time, do you have any patents? No, I have anti-patents.
So let me go into the next step then. So you mentioned that the authorization information in the authorization request is encrypted, and it can be decrypted by the issuer.
Yes.
Can it be decrypted by anybody else? So
only if the issuer outsources
is the issuer the payment processor, or is the issuer the end bank? I'm wondering.
That's a good question. And the issuer can do such arrangement if it's necessary. That means, of course, that the issuer must provide the private key to do that. So it's technically possible. I think that there are scenarios where you want to do that.
Yeah, and so what about so if it's encrypted, would law enforcement or government regulators be able to decrypt it? Because right now, um, you see frequently that the government is using transaction logs from credit cards for law
Yeah.
enforcement purposes. Would that make it difficult for them to do that, or would it still be possible to comply if they get a court order, for example?
Yeah, well, I've seen these police series where you track people with ease. That won't be possible actually with this solution. They must have a connection to the bank. They cannot just go to a merchant and scan anything, because a merchant won't have this information. But banks can do that. But so it is, if law enforcement have access to banks, they can do this.
Right.
And that
And
is
then it raises questions about the integrity when you start giving people access potentially to the key. Or I'm just wondering about it. Seems like, how would you protect the decryption keys? Because a lot of these systems, actually, the decryption keys end up getting compromised. And in the crypto world, that results in billions of dollars of loss. But it still has
okay.
made the point that it's really hard to protect these keys.
Okay. In this case, the encryption key has one purpose, and that is shielding privacy. It will, if somebody actually steals or cracks whatever, the
Yeah,
encryption key, it could lead to a privacy problem, but not to a security problem. It's a signature that stands for security, that makes sure that it's the proper account owner and
right,
does the authorization. So it would not be of the same severity if such a key is broken. But I assume for performance issues, you would probably do the decryption in an HSM,
right.
because yeah, since each payment authorization needs to be decrypted. So I would say you would do both the signature verification and the decryption in one place. That would be
Right.
the best
But
solution.
if each issuer has its own key, private
Yes,
key,
they have.
um, then they would all these private keys would need to exist only in the HSM of the payment processor, not of the bank. I don't know.
Yes,
Uh,
if the payment processor actually needs to open the authorization object, the only reason why they should open an authorization object is to get to the account number.
yeah,
They have no need for the signature public key. I can't see that. But the account number is interesting because that can be used for logging purposes, and data aggregation is, yeah, for some people it's very important to aggregate data. I am a little bit opposed to that idea, but it's technically possible for banks to outsource things like this. They can do that. They
mm,
can provide a payment processor. There aren't so many with a public and private key, or rather the opposite. And the banks, and yeah, that should be sufficient. And with a limited set of payment processors, that would not create a lot of headaches. I don't think so. But the
yeah,
original idea was actually that the issuer, the banks, would do this. We'll see about that. There are things that I don't know really, since this is yet only in a proof of concept form. That is, there are no real world deployments of this, but you can test
right.
it. It's available. Uh, that
And all these systems ultimately require both tools and rules. So, and the rules tend to be harder to set up than the technology part of it. And so, yeah,
could be,
so and the governance of these keys would be part of the trust model, I guess, for this whole system.
yes.
And yeah, I just want to we can't minimize that. Even though it's technically possible, it's still, as you know, running any PKI is difficult
I
and
know.
becomes one of the main considerations for
Sure.
operating cost.
I know.
Yeah.
The EMV model is rather simple, though it's not really as CS, since the issuer and the relying party is the same organization in most cases. So it's
Hmm.
simpler.
And
The organization have
also,
to
there's
trust
no,
their own.
it
Yeah.
doesn't encrypt the authorization response. So it basically doesn't have this feature that you're proposing for improved privacy.
No, it's the wallet that does that based on a public key that is a part of the payment credential. That means that the payment credential contains a private key, which of course is not exposed, a public key, which is used in signature, but also a public key for doing the encryption. And all these things are associated with the issuer. That is the original model. But as I said, it's technically possible to delegate the decryption part to a payment processor if needed.
One of the features you talked about was non-direct payments. I'm
Yeah.
not sure our audience knows what that is. Maybe you could just walk through what a non-direct payment is
Yeah,
and why this maybe raises some challenges for a payment system.
it does. I don't think that SEPA instant payment actually support this today. So that is a new requirement on SEPA. But if you, for instance, fill up your car, what happens when you authorize the transaction is that you authorize a maximum amount, like $200 or something like that. And
Yeah.
then
Gas must be really expensive in Europe.
gas is very expensive here. It's
$200
$200.
would fill like, I don't know, 7 of my cars.
Okay, great. Okay. I think it's 100. Yeah, I think it's around $200 actually. Um, Anyway, so the merchant does an authorization or gets an authorization of, let's say, $200, and it's sent to the bank. And if everything is okay, there is money, the money is reserved. And the merchant gets some kind of handle back to this reservation. And when you're ready with filling up the car, you send sort of a second request. This is without the wallet. Then it's the merchant, or rather the petrol station, then that sends a request for clearing this reservation with the actual amount used. And for the receipt function, it's also the moment when the petrol station actually creates a receipt, because the 200 is just a reservation, which if it's not used, it will just expire after an hour or something like that. So that is a multi-phase and payment, but there can be others like subscriptions as well, where
Uh-huh.
you say that you are going to pay a certain amount every month or something like that. Then you
Mm.
authorize it once with your wallet, and then the rest is the merchant or whatever it is that takes money each month or something like that. And that is an important scenario.
So you're saying that a richer authorization request can specify something like a recurring payment. And right
Yes.
now, the current payment systems tend to authorize one transaction.
Yeah, the SEPA systems only do that. For card payments, I don't think they have this kind of resolution. It's sort of hard-coded in the Saturn wallet. It is expressed explicitly. That means that an authorization is marked. This is for a recurring payment or a two-phase payment or something like that. And that is rather important. So it cannot be misused. An authorization can, one-off authorization can only be used once. That's very important. while something like a gas station payment can be used twice, so to say, or yeah, something like that.
I have one geeky question for you. I see we're
Yeah,
running up above on the top. I just want to get my geeky question in. I
yeah,
saw that your spec uses CBOR, um,
yes,
and I noticed that CBOR also has some draft specs, the IETF, about, I guess, proper encoding, deterministic encoding.
yes,
I,
exactly.
we're looking at CBOR ourselves for authorization as an authorization better way to, let's say more efficiently pack a
Yeah,
JWT. But I'm
okay.
just wondering, what was it about CBOR that you liked, and what improvements did you see by using CBOR?
Okay. Yes, that's a very good question. Okay, we're running out of time. Yeah,
We
CBOR's
can go over a little. It's okay.
deterministic encoding is very simple to do. I wrote a full-featured serializer in JavaScript that is only 300 lines of code, and that is including deterministic encoding. So in my tools, deterministic encoding is default. With JSON, you run into either you have to use base64 encoding over everything, or
Hmm.
you use my RFC 8785, which is sort of a canonicalization system, which it's used by some people, but I felt that this is a sort of a non-optimal solution. With deterministic encoding, you can just forget about it. Everything just works. You don't have to worry about canonicalization. It doesn't exist. Either it is correct or not, and it's really super simple to do. And of course, binary is more efficient than hex, and there is also a text counterpart which I use both for input and output, that makes it easy to handle complex documents for configuration purposes and test purposes, and called diagnostic notation. And it's actually quite useful. So I have decided.
That's really interesting. We're suffering with
Yeah,
one of the things that we're doing is we're converting JSON objects to YAML to make it human readable. So the testers, because otherwise the testers see some binary blob and they don't know what's in there.
yeah,
And and so we're actually converting that to YAML so that we can have multi-line and we can actually really read it as human beings reviewing code. Um, so I don't know. I think we should look more closely at CBOR and maybe change to CBOR as the format. Um,
yeah,
well, I guess so. We've been talking about Saturn. You mentioned you have written, I guess, a demo wallet and are doing some POCs.
yeah.
Does Saturn have any chance of getting adopted in the real world? And what would that even look like? For what would have to happen for that to even happen?
Very good question. I see a connection with this EU program, because an identity wallet is great, but you actually do payments much more often than identifying yourself. I think so, at least in the bigger ways. So I see that they must combine them and these things. And I'm going to have a meeting with the European Commission together with other payment people the 29th this month. So because they see that, okay, this is an opportunity, but also a problem, and we must solve it, essentially.
Um, we have one question talking about NASCAR problem, but yeah, we can answer questions on the LinkedIn page after this. Um, and I guess before we wrap the episode, Anders, do you have any last thoughts you want to share with the audience?
Not really. Thank you very much for having me.
And so next week, before we do that, I just want to remind everyone to subscribe to the Identerati Office Hours page on LinkedIn. There's always a link on the bottom to the LinkedIn homepage. We're trying to get to 1,000 subscribers. We're almost there at 750. We get special LinkedIn privileges when we get to 1,000. So please do that. Next week, we're talking about demystifying non-human identity, NHI, with Ryan Bradley and Carl McInnes. So that should be a great episode. Non-human identity or workload identity. This is one of the hot topics right now in identity. What do we do with all of these? How do we do identity management for these non-humans? So with that, thank you for joining us, and we will talk to you. We'll see you next week. Thanks, everyone.